Hey, you've tuned in to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged. My name is Dan Klamert, and I lead the Wireless Center of Excellence here at Cisco. And this week, I'm excited here for episode 9 of Unplugged. We're going to be discussing enhanced RRM, or radio resource management. And I would like to welcome our speaker today, Travis Youtsey from Carmel, Indiana. Welcome, Travis. How are you doing today?
Hey, Dan, I'm doing good. Thank you. I'm fired up, ready to go. I told my son I was going to be YouTube famous today.
Perfect. Thank you for being here. Looking forward to it. So before we get started here real quick, I'd just like to remind our viewers and everyone here of a couple quick things regarding questions. So if you have questions you'd like to get answered here during the broadcast, you can do so by using, if you're using WebEx, you can see, you will see on the right-hand side, there's a Slido Q&A panel. You can submit your questions there. We have engineers standing by here, team members standing by, ready to answer those questions. Also, if you're watching via YouTube, streaming there, you can click on the URL for Slido down below the video on the YouTube page, submit your questions there via Slido, and we'll have people standing by to answer them online here. Or if we have time, we may interject some during the broadcast here live. So just wanted to remind everyone also that in addition to being streamed on our YouTube channel, it is being recorded and will be available for later viewing there, like all of our other previous episodes. We've had lots of great episodes. Like I mentioned, this episode 9, and then we also have other content out there on our YouTube channel. And you can get there at youtube.com/@getunplugged. And I'd encourage you to subscribe to the channel out there. You'll then get notified when we do go live for future episodes. I know that also this week we are up against Cisco Live. So if you do we have several team members out there, and if you do happen to be out there or and you run into any of us, please say hi, and we'd love to chat with you and catch up. So that's it for the reminders here. I will now turn it over to you, Travis. Take it away. On with the show.
Hey, thanks, Dan. So today we're going to go over AI Enhanced RRM. So this slide is, somewhat funny, somewhat sad, I guess. We've got our expectations, right, of our users when they come in for Wi-Fi, right? They think it's plug and play, right? You can just throw throw APs in the ceiling every so often, right? And I'm going to get gigabit speeds flying, right? Full bars. I'm going to come in and I'm going to have a seamless experience. It's going to be awesome, right? When we know then the reality is, right, RF tuning is usually required, right? Unless you're in some single-story building with just yourself and you're only got one floor, right? No challenges, right? High ceilings, high density, anything like that, right? And, maybe you get 10 megabits per second, right? In a high-density deployment. Hey, man, you're doing great, right? Sticky clients, for those who don't know who sticky clients are, right? Sticky clients are those stubborn guys that when you first come into a building, they get onto an AP and then you start roaming around, and no matter how garbage the connection gets, right, we're just going to hang on to that AP for dear life, right? And we're not going to roam to a better one, right? And then we have bad client drivers. That happens, right? We all know client drivers control the roaming. And then there's random disconnects. I mean, who knows why? There'd be a million reasons why. They could have gotten an elevator or in the stairs, and maybe they didn't put Wi-Fi in there, right? And they're on a call or doing something, right? But the nature of RF itself, it's dynamic. So even if we have the same building on a Monday, it might not look the same on Tuesday. It might need changes. It might need an adjustment, right? We can also be interfered with from other devices. There's also the concept of noise, right? And I'm not talking about my neighbors, Carlos and Ray, that are out there having margaritas, rocking 80s band music, right? I'm talking about the kind that lowers my SNR and makes my system not perform well, right? And then I've got lots of users. We're not at home where I've got 2 or 3 people on, right? I'm talking about we've got hundreds of thousands or tens of thousands, right? So we've got challenging things that happens in our environments now. So what can we use to mitigate or help us, right? And that's where radio resource management comes in. So What does radio resource management control? Things like flexible radio assignment, right? So should I be on software-defined radio? Should I be on 2.4 and 5, or should I be dual 5, right? Should I on the radios with 3 radios with 6 gigahertz, right? Should I be on 6 gigahertz or should I run dual 5, right? Those things are all covered inside of RRM. Transmit power control, right? We don't want to have co-channel interference running rampant. How do I control my power so that I don't have those problems, right? DCA, dynamic channel allocation, right? What channel should I be using? Dynamic band selection. Should I go 20, 40, 80? What width should I use, right? These are all questions that we have to ask ourselves, you know, if you wanted to do it statically, but with RRM, we can make a couple of settings and then we can let the system choose those things for us, right? So who uses RRM, right? Does just a couple people, half our people, right? We're looking at somewhere around 99% of our customers today run their wireless using RRM, right? And some of our biggest customers do it. So how do we improve RRM, right, today? We can use AI RRM to do some improvements over the way we've done it in the past, right? So if we talk about traditional RRM versus the AI cloud RRM, right? Our optimizations and the changes we make, they're very reactive and somewhat limited by the resources inside of the WLC. The WLC doesn't have a ton of compute, doesn't have a ton of storage, right? We can't leverage those things. But when we include AI cloud, right, then we can use the compute, use the resources in the cloud to provide us with some optimizations, right? And use that AI power to comb through the data and find the best results that we can do, right? So, and then when we talk about configurations, right? In the old system, traditional RRM, there's a lot of switches. There's a lot of things that you can configure in there, right? With AI RRM, we've somewhat streamlined that. We have the basic configuration. We also have an advanced configuration where you can get a little bit more detailed and you can do some of those more advanced things, right? But also with AI Enhanced RRM, we have recommendations, right? The system can look at your data, right, and see how it's been performing, and we can come back to you and say, hey, we'd like you to try this. We'd like you to try that. We think it could improve your overall experience, right? And we don't get that today. Visibility, right? If you're looking for things about how RRM performs today, right? If you're using the old system, you don't get a lot of visibility, right? Again, because like I said, there's not a lot of storage, there's not a lot of compute. I can't keep that stuff in there for a very long time, right? When we talk about the new AI RRM, we get visibility into all the RRM decisions. We get per site RF analysis, and all of it is put up on a very nice dashboard that can give us per site analysis, right? And then if we talk about troubleshooting, right? Troubleshooting RRM in the past, right? We needed things like the config analyzer, right? To offload all the information so we could sort it and we could look at it in a good manner and make some recommendations, right? But now inside of AI RRM, we have the concept of 30-day time travel, and we also have the ability to download all that information into one zip file. All right, so AI RRM and architecture and how the data flows, right? So we have our controllers, we have our APs, and then you have DNA Center. Now, the information, right? AI is built on the AI cloud, that the information is pushed from the controller and the APs up to DNA Center, the RF data. And then the information, whoops, wrong way. The information is anonymized and the RF data is sent to the AI cloud, right? The AI cloud then churns through, makes its recommendation and changes that it wants to make, pushes it back down to DNA Center. It looks at 2 weeks of data, right, to try to understand what should we do, what recommendations we should make, right? Because the system is proactive, right? We're trying to get ahead of things, right? We're not trying to be reactive. Oh no, something just happened. What should I do? We're trying to get ahead of it with AI RRM. And then if there's, it gets populated inside of the RRM control center, right? And then any decisions are then configured, pushed down to the controller and then to the APs. Now, this is the AI RRM control center. This is when you go into DNA Center and you go into one of the facilities that you have set for AI RRM. There's a whole page here, and don't get concerned. I know things might be small. We're going to step through each part of this actual control center so you can understand all the things we have going on. But at the top, we have RRM summary. We have an RRM simulator over there on the right-hand side. We've also got those AI-driven actionable insights that the system has come back and asked us, hey, we might want to make these changes. We've also got these nice dashlets, and we're viewed in either the latest data, or you can view it over a trend, right, over time, and see how it's changed. So you get all this information. So the top part is really where we set, starting at the top left, right? We've got our time. Same thing in DNA Center. We got this concept of time travel, right? So I want to see whether it be 24 hours or whatever time you have set there, right? We can set that. We can set the band. You want to look at 5, 2.4, or 6. We also have the AI profile. That is basically your RRM settings, right? That get applied. Those are telling you at the top that this particular site is using this profile, right? And then it says the next RRM run. It's telling you the next run is going to run is in 23 minutes and 54 seconds, right? So then you go to the next line, right? And we can tell you the summary, total APs, the total amounts of clients that you have on this site. We've got an RRM performance score. It's a metric. It gives you out of 100, right? It gives you a metric score and tells you how well the system thinks your RRM is performing. We've got percentage of APs with high co-channel interference, right? Those are things we need to know. If we got a bunch of APs, what's the percentage of my APs overall that are experiencing a high co-channel interference? And then it tells you how many changes it made in the last iteration. And then from an RF coverage standpoint, we even go as far as to tell you from an AP density perspective, how dense we think your network is, right? And then we also give you the SNR on the clients. And then we have the AI RF profile simulator on the far right, and we'll get into that. And then you can see the insights. The insights is what the AI has come back, the cloud has come back and made recommendations for you to do some changes, right? We see some things that we might be able to improve upon. If you'd like to use them, you can. If you don't, that's perfectly fine too. You can just keep it the way it is. Now, when we look at that, we look at those changes recommendation, or if we run the RRM simulator, right? What it does is it runs whatever changes were recommended or whatever changes you'd like to make. And then it says, hey, here's what the change would look like, right? Here's the RRM changes we would make. Here's the overall RRM performance. Did it go up? Did it go down, right? So co-channel interference, is my change going to overall lower or raise the co-channel interference, right? So, a lot of times we have some ideas in our head of like what we could do to improve things, right? In this way, we kind of let the system do the math for you and try to figure out, hey, if you did make this change, here's what would improve, here's what wouldn't improve, here's the changes that would make, right? So we give you the ability to actually exercise on some of those ideas that you might have or the insights that the system has already given you.
Hey, Travis.
Yeah,
I got a couple questions actually here.
Sure.
So what version of DNAC did AI RRM start or begin in?
I think it started in 2.3.5, but I think it's at the end. I think the minimum requirement, so we can look at that.
Okay,
at the very end. I got the minimum requirements in the last slide.
Okay, thanks. Sorry to put you on the spot there. And then
there's
another
problem.
question. I believe they mean AI RRM, but they are asking, is RRM supported on 8540 controllers?
8540, no, I think it is 9800s only.
Okay.
And we'll get that again at the end. I think it's 9800s only, and you have to be on a minimum of 1792, right? So that gives you a clear indication of where you need to be from a hardware standpoint, right? Can I get on 1792 or not, right?
Yeah. Thanks. Appreciate it.
All right. So as we get back to that control center page, right, we get to the dashlet part, right? And the dashlet part tells us, it gives us a nice graphical view of the RRM changes that were made, any FRA changes that were made, how my RRM has been performing overall, and then, how my co-channel interference has been going. It's telling you, how many APs here and there, how many changes have been made. There's also the ability to drill in here at the view details, right? So if we do that, if we drill in, let's say, for example, on RRM performance, we can go to the top here where it says location. You can see it gives us a time. It gives us a site, right? A building 18, and then it shows us the band, right? And then you select either the poor, fair, or good APs in the graph, right? And that, in this case, I've selected poor. And you can see then it populates all the APs, right, that are in that particular poor section, right? So these are all the APs that are particularly poor, right? And then it's going to show us, it's a composite metric, RRM performance, right? So it's going to show us all the key pieces of that metric, right? Neighbor, interference, noise, and client, right? And then it's going to show us what they scored in each. And then if you actually click on the actual score, like I did in this case down here, it will give you everything that goes into that score and then how it's scored in each one of those measures, right? So in the first case, you can see interference on the current channel is 40%. That's poor, right? So then it goes down and it fills in the other gaps for you. So it's not something ambiguous, right? You're not just saying, oh, it's just interference. I don't know what that is. Would tell you what it is, right? And then we go back to that main page, right? And as we scroll down, this is the next section below the dashlet. So what we're seeing here, right, is we get to see the utilization per channel, and we also get to see AP radios per channel as well as radar, right? So on the top part of the graph, this is utilization per channel, right? I can see things like interference. I can see things like utilization at a channel level, and I'm not looking at just one channel. I'm looking at the whole spectrum here, right? And the same thing on the next graph down. The next graph down is showing me all the channels and then how many radios are on that it sees on that channel, right? So you can see on the left-hand side, it says radios, right? So in the first line there on channel 36, it's basically telling, I got 3 radios, right? 3 radios on channel 36. The other thing it'll show you in this graph, it's nice, is if you're hitting any kind of radar, right? So radar would show, and it would show with that yellow, the yellow color, and it would show in the particular channel that it was taking the hits, right? So then as we scroll down, now this is the very last of that main console page, right? We have what we call the RF coverage. Now, you'll see at the top there, it says metric explanation. You'll see it's around that. It's like a little blue circle with a little, looks like an eye in there, right? That is littered literally all throughout this actual ARRM page, right? And what that does is you put your cursor over it, it's going to tell you exactly what that thing is, whether it's a graph, whether it's a, whatever it is, it gives you the description and definition of what that is, right? So if you have any question, hey, what's AP spatial density? Hover over that little circle there, and it will pop up a little box, and you will be able to see exactly what we're measuring there. What is that, right? So it's littered everywhere. All right, so this is the RF coverage section, and we have 2 dashlets here. We've got AP spatial density and power distribution. Now, on the AP spatial density side, right, what we're showing you, right, is the percentage of radios and how many neighbors they have, right? Based on how many neighbors they might have, right, that can give us an idea of how dense you might be, right? I mean, if you've only got a little teeny tiny amount of neighbors over there at the 5, right, 5 or less, you're either extremely sparse or you are in a spot where you only have a couple of APs, right? And then we're going to coordinate that with that purple line that's going to show you essentially your client count. Obviously, we want the bulk of our clients, right, in the densest part of our network. So if you see that purple line that's over there on the end, right, and you see a bunch of clients in an area where we don't have a lot of APs, that would tell you, maybe I need to make some changes, right? But we can coordinate that. And that's how we understand, your density of your overall network, right? And then on the right-hand side, we've got the power distribution, right? Power distribution is going to tell us the AP power level. So for everybody that's familiar with the AP power level, you can see the Cisco AP power level. We go 1 through 8, right? With 1 being the max, 8 being the min, right? And so what happens is if you've got a dense network, the radios should start powering themselves down, and you should see a bulk of your APs most likely in the, 7, 8, 6 range, right? And then, you've got your higher power down there in the 1, 2, 3s, right? So we really don't want to see a lot of 1, 2, 3s, right? That means we're sparse and we don't have a lot of neighbors, and so we didn't have to power down our radios, right? We want to see the bulk. Realistically, in a high density deployment, you want to see the bulk of your APs in that lower range of power distribution. And then again, we got that purple line showing you where your where your neighbor count, right? Neighbor count is. And then as you get down to the bottom, we're going to show you the service bundle part. The service bundle part, right? You could just download it, and it's going to download the last hour of data. Boom. And it's going to include all the raw metrics, right? All the raw data that goes into all these decisions and all the graphs that you see. But then, so if you wanted to take that and you wanted to comb through the data yourself, you can do that. You want to give it to TAC because they're troubleshooting a problem, you can do that. And then you can also download it beyond that hour, right? If there was a specific amount of time, a larger time, a day, a couple hours, whatever it is, you can then set your time period there, and then you can download that information. Again, you could take it through and you could troubleshoot, you could give it to TAC. All the raw data is there for you, right? So we're not just giving you a bunch of graphs and everything. We're also giving you all the data that goes behind it, right? So if you needed to troubleshoot and go through it. All right. So then again, this is one of those when I've clicked into details, this is that AP spatial density. This is going to give me all the information, the more detailed information about what's going on in this case. So you get the APs, right? You have all the APs, and we're also showing you how the neighbors, right? How many neighbors each AP had. We've got each AP named, right? And then we've got some other stuff that's really helpful, right? We've got the total received neighbors. We've got highest on-channel neighbor RSSI, like how high is that neighbor coming in that's on the same channel that I'm on, right? And then the last one's basically showing you the total number of neighbors on channel, right? In this case, there's 1, and then the other one's got 9. The nice thing, again, is if you put your cursor over, in this case, I put my cursor over that 1 down there, it's giving me the name and the signal level of the AP, right? So it's going to list out all the APs that are on the same channel as you, as well as what you see, what signal they see that coming in at. So there's a lot of detailed information in here to give you an idea of what is going on in your environment, why things are, RRM's making the decision it's making. So then how do I turn it on, right? So the thing I need to do is I need to create an RF profile. RF profile is basically what goes on in your RRM settings in your controller today, right? We can do this in 2 ways, right? We can do it in the basic settings. We can just have you go in, right, and just say, hey, what bands do you want? And, do you want, FRA turned on? Do you want channel assignment? What do you want? TPC, all that. Do you want that turned on? The other thing it's going to ask you is for busy hour, right? So it's going to say, hey, what is your busy hour, right? I need to know when you're most busy. I can find that out over time, but right now I'm just asking you. So basically you give it business hours. Why do we need that? Because we need to know, right, when you're actually utilizing the network so we can try to keep the changes to a minimum, right? And we've also got that sensitivity button here where we can set low, medium, high on those changes, right? And then, so you can do that and RRM will go, right? Or if you're one of those RRM junky monkeys, right, that likes to play around and get in there in the nitty gritty, we can get into the advanced settings, right? So we have all the different DBS bandwidths. We've got the channels. If you want to select the channels, right, we've got all the advanced configuration that you can go through. So you just configure this RF profile, then you assign it to a site, and then RRM will start to work. Now, how do I turn on overall RRM to get it up and running with DNA Center and connected to the cloud, right? This is what the whole thing that you want to do, right? It's easy as 1, 2, 3, right? 1, we just turn it on, right? We go inside DNA Center, we go in, we hit those buttons right there, basically say enable AI network analytics and enable AI advanced RRM, right? Then we go in, we create that AI RF profile that we just talked about, right? You can either do it the simple way or you can do it the more advanced way. And then we go and then we assign it, right? We assign it to a particular site, right? And then it will then use those settings to start, building your RRM. And then at the end here, we're going to look at those minimum requirements, right? Dan talked about it earlier. What are the minimums, right, to get this up and running? So Cisco DNA Center, you can do 2.3.3.6, or if you have Wi-Fi 6E enabled APs, you got to use 2.3.5 because the AP has to be supported, obviously, on the platform. We've also got it. You have to use 9800 and you have to be on 17.9.2 plus. For Wi-Fi 6E support. And then from a AP perspective, right, you're looking at Wave 2 and your 9100s or the CWs that we have out now, right? And that's really the end of it. Dan, do we have any other questions?
Right now, no. It looks like we're caught up on the questions. We had a couple that came in, but they were addressed So thank you, Travis.
All right. Hey, no
All right.
problem.
Thanks. Great deep dive there on AI Enhanced RRM. Appreciate it. That was awesome. And just before we wrap up here, just wanted to remind everyone to please complete the survey when the event closes here. We appreciate your feedback always. It helps us, think of ideas for new shows and improve these shows moving forward. So thank you. And then also, again, I would recommend, or I would like to remind you that Cisco Live is going on this week, like I mentioned. So if you're out there, great. Stop by if you see us and say hi. Also, we do have a great recap episode coming on Cisco Live here in 2 weeks. So I would encourage you to go out and subscribe to our YouTube channel. You'll be notified then when we do go live. You can get that at youtube.com/@getunplugged. And again, you can review a lot of our great previous content out there as well, previous episodes. So if you have any other questions too, if you're not out at live, you want to reach out and engage us, you can always reach out to your local Cisco account team. They know how to get a hold of us, and we'd love to chat with you. So I believe that's it for this week, and another great episode in the books. Thank you, and until next time, stay connected and unplugged.